Hello, my name is Magir and I'm a grade 9 KC High student, and today I'm going to be presenting you an AMC 10 problem solution. A bit about me, maths has been my strong subject since 6th grade, and I've also challenged myself in the IGCSE by taking up a subject called AdMath, which our school offers. It's a much higher level subject in relation to maths compared to international maths. And I've also challenged myself by taking up the AMC 10 exam, which is in November, and we have started practicing since February. And here's one problem that I'm going to show you how to solve. Right, so in this problem 19 of the AMC 10 2020, AMC 10 is just the exam for anybody from 10th grade or lower. Anybody from that range can take the exam. And in the AMC, there are 25 questions. The difficulty increases as the question number increases. So problem 19 is probably one of the harder questions you will come across during the exam. So this figure right here, it's a 3D shape dodecahedron, which means it has 12 faces. And in this question, it's important to note that there are a ring of 5 slanted faces adjacent to the top face, and the same for the bottom face. So what they're trying to say is, from the top face, there's 1, 2, 3, 4, and 5 faces, and then the same for the bottom. So it's just the ring again. And then you have another face at the bottom, which totally makes 12. And now the question is, how many ways are there to move from the top face to the bottom face through the sequence of adjacent faces, so that each face is visited at most once? So you cannot repeat any face. It's not allowed that you can't repeat any face more than once. And you also cannot go from the bottom ring back to the top ring. So let's say you were at the top face, move to one face of the top ring, go to the bottom ring, and then you can't go back to the top ring again. That's not possible. This pathway is not allowed. So initially you start at the top face. You have 5 options. As I said earlier, there are 5 slanted faces adjacent to the top face. So you have 5 options here, so I'm just going to write the 5 right here. Then let's say you move to this face. Now from here you can stay in this face, or you can move right once, go to this face, or move right again, go to this face behind, move right again here, move right again here. Now you can't move right one more time because you came here to begin with. So you'll be visiting the face more than once, which is not allowed. So already initially we had 5 options, so I wrote the 5 there. Then staying where you are, so I'm just going to write the 1 here. Or what you can do is move right once, stay there, so that's another 1. Move right again, move right again, move right again. It's 4 move rights. I'm just going to add a 4 here. Or what you can do is the same thing but move left. So 1 to the left, 2 to the left, 3 to the left, 4 to the left. Now again we can't go back here because we'll be visiting a face more than once, which is again not allowed. So 4 to the left, so we add a plus 4. So over here these are your options. So you can either stay here or you can move right or move left. So that's why we're adding in the situation, which in this case we'd get 9. So there are totally 9 options. So I'm going to multiply by 9 over here. So now let's say you're in this face, and say we're in this face. Now we can either go to this face or this face. So from any face on the top ring, you have 2 options on the bottom ring. So we would multiply this by 2, because for each option you have 2 options at the bottom ring. And now let's say we choose this face of the bottom ring. We choose to go here. Now from here it's again basically the same thing as the top ring. We can stay where we are, so again a 1. Then we can move right once, twice, 3 times and 4 times. So 1 here, and then on the back 1, 1. So those are again 4 options. So add a plus 4. Then now again the same thing, we were able to move right on the top ring, we were also able to move left. So for the same thing over here, move left once, twice, thrice, 4 times, and that gives you another 4. So I'm adding here because these are your options. You can either go here or this way. So that's why I add, so we get another 9. Now we multiply as over here, before that. So for the total amount of ways you have to multiply, because you can go this way or you can like go around, and like you have to calculate all the possible ways that you can go from the top ring to the bottom ring. So in that case you would have to multiply and not add to find out the total amount of ways. Then if you simplify this, you get 90 times 9, which gives you 810. And then 810 is one of the 5 answers, and it is correct. So yeah, thank you.